I'm the person of Akanchok and Yellow with a registered number of 2024-070-8078, and I will be your elective mathematics teacher for today. Today we'll be looking at overgeneralization and elective mathematics, specifically a concept in elective mathematics known as what? Trigonometric identities. And our focal area is going to be on overgeneralization and these identities. But we realize that most often students usually overgeneralize using this particular one, identities. So at the end of our study, we should be able to define overgeneralization, and we should be able to give example of errors that illustrate what? Overgeneralization and trigonometric what? Identities. And we should be able to tell why this particular overgeneralization always what? Okay. So realize that if you're having a right angle triangle, so with this particular right angle triangle, if the other two sides of the triangle are given, and you are being asked to calculate for what? The longest part, we always use what? Pythagoras what? Theorem, which says that the square of the longest part should be equal to what? The square of the other side of it plus the square of what? The opposite what? Side. So if you pick h square, it should be equal to what? O square plus what? A square. So with this, we learned about trig ratios. And in the trig ratios, we have our sine, cos, and tan. And we're being told that in order for us to calculate for tan, cos, or sine, when an angle is given. Since we already know that the longest part is the hypotenuse, and where the angle is facing is the opposite, and where the angle is sitting on is what? The adjacent. To calculate for what? Sine, cos, and tan, we have been given sine to be what? Opposite over what? Hypotenuse. Then cos to be opposite over what? Hypotenuse. And tan to be what? Opposite over what? Adjacent, which we call the SOHCAHTOA, which help us to what? Remember how to calculate for what? Sine, cos, and tan when an angle is given and one side of what? The triangle is what? Given. So with this, you realize that sine is, if you're having sine of the angle, it will be equal to what? Opposite over what? Hypotenuse. And one of the identities in trig is that if you're having, so if you want sine of the angle here, it is opposite over what? Hypotenuse. And if you want cos of the angle, it is equal to what? Opposite over what? Sorry, adjacent over hypotenuse. Adjacent over what? Hypotenuse. So you realize that the identity that says that sine theta square plus cos theta squared is equals to 1 holds, in the sense that with Pythagoras theory, h squared is equals to what? O squared plus what? A squared. That is the opposite square plus the adjacent square will give you what? The hypotenuse what? Square. So with this, we can prove to know whether it is actually true that if you add sine squared theta plus cos squared theta, you will actually get 1 or not. So sine, which we all agree that it is what? Opposite over what? Hypotenuse. So we have O over H, and the sine is what? Squaring, plus cos, which is what? Adjacent over what? Hypotenuse. So we have A over H squared. So with this, we will get O squared plus A squared all on H. And this one, we said H squared plus should be equal to 1, O squared plus 1, A squared. Now we have O squared here, A squared here. So here will be what? H squared all on what? H squared, which we will get what? 1. So let's assume that this particular angle here, let's assume that this particular angle here is what? 45 degrees. So if theta is equal to what? 45 degrees. Then we can substitute what? 45 in place of what? Theta, to see whether we actually get what? 1 or not. At the end, your result is going to be 1. So that shows that the identity sine squared theta plus cos squared theta is equal to 1. It means that the identity is what? Valid. So let's substitute theta to be 45 degrees. So if you have sine sine square 45 degrees and cos square 45 degrees, the result that you are going to get, if you key in sine 45, the result that you are going to get will be root 2 on 2. But remember that sine is what? Squaring. So you square plus cos. If you key in this, you get root 2 all on what? 2 square. So with this goes with this. So we have 2 on what? 2 square plus this with this. We have 2 on what? 2 square. So which will be equal to what? 2 over what? 4 plus what? 2 on what? 4. So 2 in this side is what? 1. 2 here, 2. 2 here, 1. 2 here, 2. So we have 1 on 2 plus 1 on what? 2, which is equal to what? 1. So it means that this particular identity what? Holds. So because of this particular identity, most students normally overgeneralize. So whenever they see something like sine square theta plus tan square theta, they conclude that since the trig ratio, if you are squaring the trig ratio and you are adding them, the result should give you 1. So whenever they see something like this, they conclude that is what? 1, which is not what? Valid. So how do we know that it's not valid? So we can substitute theta by let's assume that theta is what? Theta is equal to 45 degrees. So let's substitute theta here to see whether we actually get what? 1 or not. So if you have sine square 45 degrees plus tan square 45 degrees, so sine will give you what? Root 2 on 2 square plus tan. Tan 45 will give us what? What will we get? 1. We'll get what? 1. So, and it is what? Squaring. So you realize that here you are going to get half plus what? 1. Which will not be equal to what? 1. So it shows that this particular identity does not hold. Because of this particular identity, students will usually overgeneralize. You think that adding this, you are going to get what? 1. And another one that students usually overgeneralize is, if you pick tan square theta plus cos square theta, you are going to get 1. If you are going to prove this one, the result will not give us 1. So you realize that these two identities does not hold. So now we're looking at why students do overgeneralize certain concepts. And one of the reasons is that pattern recognition without understanding. They usually just look at the pattern without actually understanding what the concept. That leads them to what? Overgeneralize. Another one is routine memorization of what? Formulas. Instead of them to understand the formula, they just try to memorize whatever that they have been taught, which leads to what? Overgeneralization. This and many more can lead to what? Overgeneralization. So in three teachers, normally to emphasize on some of the identity in order to limit students from what? Overgeneralization. Thank you very much.